Okay, let's see another one. So tangent times cosine inverse of negative 1/3. First thing we're going to do is figure out theta. So we'll say theta is equal to cosine inverse of negative 1/3. And we will use our properties to solve this. I'm going to multiply both sides by the cosine. Whatever you do to one side, do to the other. And then our property, our cosine times cosine inverse, would just give us our x value, which would just be angle theta is going to be negative 1/3. Now, we're working with this cosine inverse, so what region of our graph is that defined by? Good, the top portion. So basically, we know we're going to be in this portion of our graph from 0 to pi, but this is a negative value, which cosine, it's going to be your x value over your r value, so our cosine has a negative x. So does that put us in quadrant 1 or quadrant 2? Puts us in quadrant 2. Good. So that's where we know we draw our rectangle. I mean our triangle. Excuse me. Now let's label that. So the x value is a negative 1 and our radius value is a 3. Now we actually just did a triangle with a negative 1, 3. We know what the missing side's going to be just from our previous one right here. So a negative 1 and a positive 3 is a radius. What was our missing side? Plus or minus the square root of 8 or 2 square roots of 2. So just from the previous problem, we can pull the 2 square root of 2, which is going to be a positive value. So it's plus or minus, but in this case, our application, this is a positive value. Okay, now the last thing we want to know is now we want to answer what is the tangent of that particular theta on the graph. So tangent of theta is defined by your y value over your x or your sine over your cosine. In this case, we're going to do our y over x. What's our y value? Here, 2 square root of 2. And what is our x value? Negative 1. So the tan theta is just going to be negative of 2 square root of 2. Okay, so what if we have an example like this? We're looking for the cosecant inverse of 2. So what I've done over here is I pulled up my region, and that's the restriction for cosecant inverse. But I'm looking for the angle theta that's in our highlighted region that has the cosecant value of 2. Now it helps if I remind myself that the cosecant value of 2 is the same thing as looking for the sine value cosecant that would be the same thing as looking at for the sine of theta is equal to 1/2. So where is, go to your unit circle and look over here in this region, and where is the sine value 1/2? So the positive 1/2 for our y value is right here, which means pi 6. So when I'm looking for cosecant, sometimes it helps to just look at its reciprocal function, which just do the reciprocal of this. Reciprocal of 2 over 1 is 1 over 2. So go find where the sine value is positive 1/2, and that's going to be our solution. So our answer is just going to be pi 6. Okay, so if we do secant inverse of negative 2, first thing I did is I highlight my region and my restriction. So my mindset is I know I'm looking for an angle in this region. So an angle in this region whose secant value is going to be negative 2. Now, secant theta equal to negative 2. Well, secant is the reciprocal function of cosine of theta. So if this is a negative 2, what are we going to look at for the reciprocal? Negative 1/2. So cosine's your x value. So go find the x value of a negative 1/2. Negative 1/2 right here. X value of a negative 1/2, which means this, and that is this equivalent statement as this. So we would have our solution to this problem is going to be is equal to 2 pi thirds. Okay, our next set of examples are going to be using the calculator just like we did in the previous lesson. And so this first one is secant inverse of 3. And look at your calculator and tell me what you think. There is no secant inverse button, correct? Good. So since there's no secant inverse has the same region as which one of the trig functions? As our cosine function. They have the same, except for the restriction of where it's undefined, they have a similar region. So we can keep in mind, kind of like we did a minute ago, I can rewrite this as, instead of looking at the secant of 3, I can look at the cosine theta of what? What's the reciprocal of a 3? 1 over 3. So what I want to do is put that in the calculator as theta is equal to cosine inverse of 1/3. So basically you just want to use this idea to rewrite this. Okay, use this property. So I'm going to rewrite this as our cosine inverse of the reciprocal. Now this we can put in the calculator. Make sure you do second cosine and then you put in that also that your calculator is in radians, so it's approximately 1.23. Okay, cosecant inverse of -4. I do not have a cosecant inverse button, so I'm going to use my property and rewrite this as what? What has the same region in our inverse function as this, but except for the restriction, would be sine inverse of, what's the reciprocal of a -4? Which is -4 over 1. The reciprocal of a 4 over 1 is a 1 over 4. And don't forget to keep your sign. So this is what we want to plug in the calculator. And you should get approximately -0.25. Now, what's real important to note is that these have the same regions, like I said, except for the restriction. This is in the top portion, this is in the top portion of our graph, this is in the right, this is in the right. But let's look at this next example. Cotangent inverse of 1/2. Let me flip back. Cotangent is in the same region as, let's go back to that page that we did. Cotangent is in the same region as which one of these up here? Cosine, right? So that's the one that we're going to use, but it's not as fluid as the other one, as in just being able to pull the reciprocal by the trig function, because cotangent and cosine didn't necessarily have a relationship like the other one, didn't have that reciprocal relationship like the other one. So this one's going to take us a little bit of work. So I want to be able to write that as a cosine inverse of something. But the first thing I need to do is I'm going to recall some basic stuff. So the cotangent of theta is defined as the x value over the y value, right? The cosine over the sine, x over y. So if I first of all go there and I put my x value and my y value, first of all, cotangent inverse is going to be up here. So I'm either going to be in quadrant 1 or I'm going to be in quadrant 2, but this is both positive. So it tells me I'm going to be in quadrant 1. So the first thing, I'm in quadrant 1, my x value is a 1 and my y value is a 2. So I've got to label this thing. X value is a 1, y value is a 2. How can I find out this missing one? Pythagorean theorem, yes. I'm going to pause it and do that to the... Okay, good. So some scratch work, which we did this one previously today. So we have square root of 5. Now I need to rewrite that. What is our cosine? Because now I've got to translate this into a cosine value. So the cosine, let's just remind ourselves over here to the side, cosine of theta is going to be your x divided by your radius. So what is our x value of this? 1. And what is our radius? Square root of 5. Okay, this is what we're going to plug into the calculator. We don't have a cotangent button, so we don't have that option. We had to choose cosine inverse because it was the function that had the same region that we're restricted to. Then we had to use this information here to convert us from a cotangent inverse to a cosine inverse. Now we're able to plug this into the calculator, and you should get approximately 1.11.